Okay, good morning. This class is ECET323 and the Signals and the System. This one is engineering class. You already know that, right? And it's very hard, very difficult. We are EET students. And even for engineering class, for engineering student, it still feels very difficult. Right? But in this class, we try to explain things in a technology way. Right? We do not discuss a lot of theoretical derivations. But anyway, it's still hard, so be prepared. The class has a website, and it is HTTP and OCA. And this is my website. You go to this. On the left-hand side, you click Teaching, and there will be a list of courses I'm teaching this semester. So you click the EET323 and ask your password. The password is signal. Right? You input the signal, the password, and then we have to go to the class website. And the syllabus and the homework and any other announcement will be on the website. This is a 3-hour class. So we are going to have like 25 midterms, then plus 2 midterms, and plus 1 final. Anyone has the textbook? Not yet? I'm not quite sure if bookstore has a textbook yet. Okay? So you can buy online or it's supposed to be in the bookstore. The textbook is the fundamentals of signals and systems using the web and the MATLAB, the 3rd edition. And also the lecture notes is important.
What's the name of the book again?
It's the fundamentals. I'll tell you the ISBN. It's 978 and 013 168 7370. It's called the Fundamentals of Signals and Systems. This course is Introduction to Signals and Systems for junior and senior students. It's required for both EET and CET students. We are going to basically have 6 major topics in this class. The first one is continuous time signals. Second one is continuous time signals and systems. That's the first one. The second one is discrete time and signals and systems.
What was CT?
Continuous time. Continuous time signals and systems, like a sine function, cosine function. I believe almost all of the signals we learned in in 101, 110, 111 are continuous time. So, for example, the voltage, the current, everything is a function of cosine or sine. So that is continuous signals. So the systems are continuous systems. Discrete time means the signals will be discrete. Like one special is a signal, digital signals, 0 and 1s. And the system is, for example, different systems. So we are going to discuss more. The next one is Laplace transform. And the inverse Laplace transform. Laplace transform convert time domain signals into Laplace domain. Right? So theoretically, it's very simple. It's just integration. So for example, if you have a time domain signal here, which is a function of time, then what you do is you multiply e to the negative st exponent, then you do the integration with respect to t. We know after the evaluation of the integral, this t will be gone, right? And we all have only a function of s, right? So we call this one as x, capital X, corresponding to the small x, which is a function of f. So this is the Laplace. Right? So I'll give you, for example, a lot of typical signals, step functions, and you do this integration, then you get the Laplace transform. Right? Inverse Laplace transform is you are given this one, right? The Laplace of the signal. Then you multiply by e to the negative st. Positive st. This one is negative, this one is positive. Then the integration is with respect to s. Right? So after the evaluation, this s will be gone. So we have only a function of time. So this one here, this is capital X, which is Laplace. Right? And then what we have is the time domain signal. Okay? You can see here, this one is continuous. So this one is a continuous signal. Right? And this one is also a continuous signal. This one is this. We are going to discuss the techniques and the properties of Laplace transform and the method of inverse Laplace transform. So that's two. The next one will be Z transform. Z transform, you can see from here, continuous time. So this Z transform is applied to a discrete time signal. Discrete time, this one here we say, okay, xt, and this one here we can say x, n, use square x, square bracket, this one is n, not time. This is n. N equals 0, 1, 2, 3, or negative 1, negative 2. So integers. So Z transform is applied, is very similar to Laplace transform, but instead for continuous signal, it is applied to a discrete signal. So over here is xn and equals, in discrete, we do not have this integral because the integral will be just a summation. So it will be the sum, and this xn here, and e to the negative e r to the negative n. This one is z. Okay. This is capital. And this is the summation with respect to all n's. So after the evaluation, the n is gone, so we have only a function of z. Then the inverse Z transform is similar to this one. And also we are going to discuss the properties and the method for Z transform and for inverse Z transform. The chapter 5 is system analysis. It's a continuous time system analysis. What we do is we have a continuous time system. Then, for example, like this, we have input x, t, and we assume we are going to have a continuous output. We do not directly analyze like this. Instead, we take the Laplace transform. So we get s here. Then we analyze this system. So we get a y the Laplace transform of the Y signal, the output. Once we get this, then we take inverse Laplace transform, we get the original output. So we take extra step here, extra step here. So in the first chapter, we know the signals, continuous signals, X, Y, and we know the continuous system. And in the third chapter, we know the techniques for Laplace transform and convert this xt into xs, and the inverse Laplace transform convert ys into yt, and in this one here, this is transform analysis to analyze this. So that is chapter 5. Okay? Then chapter 6 is very similar. Right? So discrete time system analysis. Right? It's very similar to this one. So we have a discrete time system, we have discrete signal, and we use the Z transform and the inverse Z transform, we analyze that. So basically, these are the 6 major topics we are going to discuss in this class. So any questions? We have listed objectives, course outcomes. You look at you read the syllabus, and that is what we are. So you know that. Homework. We are going to have a weekly homework. Usually, I give you at least 1 week before the due time. For example, if the homework is set today, then it will be due at least next week. You have at least 1 week to do that. The total number of homework set is about 8. Okay. Each one will have like 3 or 4 questions. Examinations. We are going to have 3 examinations. 2 midterms, 1 final. All tests will be closed book, but you can have 1 piece of paper, a letter size, both sides. You can write any information you want, but you need to hand write by yourself. Any questions on this? For the grading, the attendance is 10%, and the homework is 20%, and the midterm is 20% each, so it's 40% total. And the final will be 30%. So totally you're going to have 100 points. If you get an A, that means 90 and above. F, that will be below 60. We encourage you to collaborate with each other with the homework or any questions in textbook or lecture notes. You can, if you have any questions, discuss with me, discuss with your friend. But when you submit your homework, you need to write by yourself. You need to understand before you write. In the test, there's no collaboration, right? So you just do by yourself. If you want to perform well in the class, you need to come to the class regularly, but I would suggest every time. If you have a special, some emergency, you need to skip the class, you let me know, then it's your responsibility to borrow some notes or something to catch up. We know this class is very hard. We discussed here here 90 minutes. If you do not come to the class, I think you need to much more than that to digest the contents. So I suggest better to come to the class. Class, if you have any questions, you can stop me at any time, so I can explain more. Okay? The university has a lot of supporting services like writing or speaking. We don't need that. Okay? And extra resources. If you have any need for math or for any tutorial, math department or some other offices or even school computing has I think tutoring center, so you can ask for help. And also I have all these hours, and you can seek my help. Absences, as we said, we require the attendance, so you better come to class each time. and we are going to have random quizzes, so that will give you a bonus point. This bonus point can be up to 5 points. Okay? So then you can have up to 5 points of bonus. For example, if you here get 89, add up together, then if you get 4 points of the 5, then 89 plus 4, that will give you 93. So you are going to get, instead of a B, you are going to get 8. So that's bonus point. I suggest you participate in discussions actively. If you have any questions, ask me, ask us. If some others have questions, if you know it, not quite right, no matter what, try to answer questions. So we want active participation. Okay. About the scores, I don't give incomplete scores. Incomplete means, okay, you cannot finish, then you want to come back next semester, you give you I. So usually that's not the case. So I want to help you as much as I can. So if you have any questions, for example, some emergency things, okay, let me know as early as possible. We can help before the end of the semester. Others withdrawals and drops, the deadlines are on the website also, so you need to check that. So if you want your money back, or if you do not want any bad grade in your transcript, you need to follow the deadlines. But I do not suggest to drop all the class, because we have like a flow chart, right? This is prerequisite for other courses. So, and this class is offered only once each year. So if you need to drop or withdraw anything, then it may affect your graduation. So, but before you take any actions, like drop, let me know, and we can discuss, find some alternative, to find if we have any options. Okay? Does it make sense? Academic integrity, you are seniors, the juniors, so you already know that. So everything is on the website, is on the syllabus, so you can read by yourself. And professionalism, communication device, as we said. I know everybody has smartphones, cell phones. You have a social network, you want to send email or anything, right? I know sometimes you have emergencies. If you can expect, for example, you have a kid or something, you're expecting an emergency call, you can go outside, take the call, or make the call. Do not make sound in this class. Right? And the policies here, if you need to make a call, you'd better leave the classroom, because we do not want you to affect others. No recording or videos, audios. So if you need to do this, you need to let me know. Computing devices, we do not need to use a computer in this class. So don't bring computers. If you need to have computers, put in the backpack. We may need to use calculators. So a dedicated calculator is better. Violations, if you violate the first time, you are going to get 1 letter off. For example, you get A, now you get B, -1. If you get a C, now you get a D. So keep this in mind. Second violation, I will ask you to drop the class. So don't do this. ADA statement, if you have a need of this, you need to report to the ADA office, and they are going to inform me, then we can come up with any help. So that's no big deal for this one. Okay. And we have a calendar on this, on the syllabus, and the topics. Okay, on the left-hand side, that's the unit. We have 25 units. Each unit is 90 minutes. And on the right-hand side, we have the corresponding readings of the textbook and also lecture notes. For the first homework, the first midterm, we are going to have the first midterm at this point, right? After the first 2 chapters. And the second midterm is up to this point, right? And the final is here. The final is cumulative, And all these are closed book, closed notes, but you can bring one piece of cheat sheet together. Okay? Any questions on this? Everything good?
You record your lecture and put it on your website, or just for your own personal?
This one we may want to offer online courses later time. So this is just for trial.
I got you.
I want to see that because this is the first time I use this one. Before I use the laptop, the quality is not good. So this is the first time I use
I
this one.
understand. I was curious.
But the size may be very large, so I don't know still.
Yeah.
But if you need to skip a class, you need this one, maybe let me know. I mean,
Oh, you can send us a video. Cool. Excuse me.
How to make this full screen? You know how to do that? Okay, first we discuss signals. You can read both of it, right? Okay, first one is analog signals. So anyone can explain what analog signal is? Analog signal is a function of a time, and the amplitude can be, we just write A, can be a voltage, can be current, or can be basically anything, temperature or anything. Right? The key is in the time it is continuous. In the amplitude is also continuous. For example, looks like this. Continuous means no matter you give me 2 points, I can always find 1 point in between that has a definition. Right? No matter how close this 2 point is. Right? So like this, from 1 second to 2 seconds, okay, I have 1.5. From 1 to 1.5, I can have 1.1. So between any 2 points, we have a definition. So that is basically the meaning of continuous. So in time, it is continuous, and in amplitude, it's also continuous. Right? We know, for example, sine function and cosine functions are both analog signals. So xt equals a times cosine omega t. This is like the next one is a discrete signal. Discrete signal, for example, like this. So we can see it is discrete in time. So instead of t, we use n to represent. And this amplitude is continuous. That means the value can be anything from the maximum to the minimum. So we can have 8.5, we can have 3.1415, so the amplitude can be continuous. But the time is discrete. So this is called discrete time signal. So that is the dt. The next one is a digital. Digital signal. We already know digital signal from 320 or 240. Digital signals means it's continuous, it's discrete in time, and also discrete in amplitude. So for example, binary system. Binary system, we have only 1 and 0. So 1, 0, 1, 1, like this. We do not have any definition, for example, 1.5 or 0.5. So that is discrete in binary. Next one, we discuss the basic continuous time signals. Right? The first one is a unit step. Unit step is represented by UT, unit step. Its definition is equals 1 for t greater or equal to 0, and equal to 0 for t less than 0. Different fields have different definitions. For example, for example, when t equals 0, some definition may be in math say, okay, that equals 0.5. Okay, let me plot this first. Okay, so that is t. This is amplitude. It looks like this. So this one equals 1. This one equals 0. Okay. Our definition is when t equals 0, that equals 1. Some definition give us, okay, when t equals 0, okay, that value give you half. They have a special consideration, but it's not important to us. in this class. So we just use this one. When t greater or equal to 0, that equals 1. When t less than 0, that equals 0. So that's the unit step. I have a delayed version of a unit step. So for example, ut minus t0. This one will be equal to 1 when t is greater or less than t0, and 0, t is less than t0. One example is like this. So for example, t0 equals 1. This is 1. It's like this. This one will be ut minus 1. So ut minus 1, this 1 minus 1 is here. It is equals 1 for t greater than or equal to 1 and equals 0 to the left. So that's called the delayed version of ut. How about if I want to represent, for example, 5 volt instead of 1? So in that case, we can use this. So like this, 5 ut. 5 ut means this one equals 5. Okay. Why we want to use this kind of representation? For example, if we have a source and we have a circuit, for example, this one is R and this one is C, like this. I want to close the switch at t equals 10 seconds. I will close this switch at t equals 10 seconds. So what is this input? Suppose this one equals 12 volt. So what is the input? The input xt will be, anyone knows how to represent this? Use unit step. If you want to use a word to represent this input, is okay, before t equals 10 seconds, we don't have any input. After t equals 10 seconds, the input equals 12 volt, right? That is too worthy, so it's not easy to use. Instead, we use xt, this is voltage, so we use vt. V as function of time equals 12, because this equals 12. And we use the unit step t, right, which is the function t, and definitely it's delayed to 10 seconds. So what is here?
It's 10 seconds.
Minus t, right? Okay, minus 10. Right? That is our input. Okay? So equals 12 ut minus 10. Does it make sense? Is it good? Okay. That's the first one, unit step. The next one is the next one will be impulse. This is one of the most important concepts in this class. Okay? So everybody needs to understand this. Impulse is represented by delta function, delta t. The definition is this one equals infinity, or equals infinity, right? When t equal to 0, and equal to 0 when t not equal to 0. Right? We have another condition, but before that, we draw this first. Right? So this t and this is 0. So what I draw is like this. Right? This is called impulse t, delta t. It occurred when t equal to 0 at this point, and the value equals infinity, and all other values equal to 0 if t is not equal to 0. This infinity is has a condition, and not just the random infinity. So what is this? And we have another condition is this impulse, the integration from negative infinity to positive infinity with respect to t must be equal to 1. So this, along with this, give us the definition of the impulse function. Now we explain what does that mean. How to understand this? Let me think like this. First one, we have a signal here, and this is 0, right? I make a rectangle, and this length equals the width equals 2, the height equals half. That means the area equals what? That's a rectangle. The width equals 2, the height equals half. What's the area? 1. Equals 1. Right? Now, I make this rectangle narrower, but keep the area the same. So it will be, okay, half width, then double the height. Narrow, taller. Make sense? But the area still equals 1. Right? Then I will make it even narrower and even higher, like this. Okay, in the limit, it will be like this. The width approaches 0, but the height equals infinity. But keep the area. There's no area here, right? It's a blank. But based on math, the area is the integration. So the integration will keep equal to 1. So that helps us understand this impulse. You have a rectangle, right? You make this shorter, narrower, and make this taller, okay? But keep the area the same as 1. And in the extreme, the width equal to 0, the height will be equal to infinity, but the area is still equal to 1. Does that make sense? And we know this. Look at this definition here. In addition, except this t equal to 0, this one is non-zero. All others equal to 0. So this integration will be equal to, I said, how about this one? Negative 1 to 1. For first one, negative 10 to 10. Right? Negative 10 to 10 dt. Is this one equals this? For this function, I integrate from negative infinity to positive infinity, or I can integrate from negative 10 to positive 10. They give me the same result, right? Because before that or after this, we have nothing. Make sense? Or I can choose this, how about negative 1 to positive 1? Still the same, right? Still equal to 1. All right. How about very close to 0 to the left and very close to the 0 to the right? That's still equal to 1. All right. So what we write this one? 0, but it's negative side, and this one here is 0 to the little bit to the right side. So still around 0, but very close to the 0, but left side, right side. This integration is still equal to 1. Because all the contributions from the right-hand side and the left-hand side except 0 give us nothing. Make sense? All right, so that is the impulse. As we said, this one is maybe not easy to understand, but this is one of the most important concepts. We have two conditions. The first one is the definition: when t equals 0 equals infinity, not equal 0, then it equals 0. Another one is the integration of this function along the time axis must be equal to 1. Okay, so that's. Okay, the next one. unit ramp, unit ramp, and represented by R, T, and this definition is when T greater or equal to 0, that equals T. And when T less than 0, that equals 0. So if I draw this, it will be like this. That's 45 degrees, right? Because it's RT equals T. So this one here, T, that's 0. And if this one equals 1, then this one must be equal to 1. So it's 45 degrees. So this is unit ramp. And R as function of T. Similarly, we have a delayed version, delayed like this. So this is here. So suppose this is 2. What function is this? Let me draw this. So this is 3. This is 1. What function is this? That is R T plus to the right. This is minus, right? Minus what? This one starts from 0, and this one starts from 2. So it's delayed by 2 seconds. So that one is T minus 2, right? Does this make sense? So that is R T minus 2. Okay. Next, I want to do this. Look here. This function. And this value here, for example, equals 4. So this one here is this one. What is this? This is delayed. This one is amplified, multiplied by constant. So we still have R T minus 2. That does not change, right? Because it's delayed by 2 seconds. Now what is the amplitude? Look at this one. This is 1. For every change of 1 in the T, how much is the change in the amplitude? This change from 2 to 3 is 1. From here, that is from 0 to 4, right? So the slope equals 4. So this one is 4R T minus 2. Yes or no? It's good? Okay. These signals are important. We need the one application is we can represent a signal with these basic signals. For example, I'll give you a system. The input looks like this. Okay, I said the input like this. This is T. This is 1. That is, okay, keep 1. We have a signal here, and we have a system here, and we have a switch. This input will follow the pattern like this. When T equals 0, this equals 0. When T equals 1, it equals 1, but the linearly increases. Then after 1, it will keep a constant 1. So our question is, how to represent this signal, xt, with this basic CT signals. Anyone want to try? First one, we can see, oh, this one is a unit ramp, right? So definitely, this one equals unit ramp. That is this part. But if you write only this, that means this one will go all the way up to infinity, right? We don't want that, so we need to. We need unit step, right? So we plus unit step. What is this? Unit up, unit step. It won't be constant. It will still going up. But what we want is just flat. So only this. Is this good? Does this represent this pattern? Okay, actually, this one is not correct. Okay? So we need to change. Okay, let me break this down. First one like this. Second one like this. Now, this signal plus this signal, what do we expect? This signal plus this signal.
Be a smaller signal.
Okay, let's see. At this point, because this one equal to 0, right? We add up together, doesn't change anything between here. So this is 1, this is 1. So we still have this one. Make sense? This signal plus this signal. But before 1, it is only this part. And then all this is 0 here. Like this. Make sense? Okay, after this one, this is up, this is down. They have the same slope, but this one is positive, this is negative. So they kind of cancel each other. Right? So for example, this equals 1 here, this one equals 0. So this one minus this give us 1. Right? So it is 1 here. How about this one here? This one equals maybe 2, right? This one will be maybe negative 1, because it's the opposite way, right? So 2, negative 1, add equals what? Equals 1, right? So equals 1 here. How about here? This one may be 10, but this one will be a negative 9, because it's delayed by 1 second. So 10, negative 9, add up together equals what? 1, right? So that's equals 1. So you can see all other times add up together, it gives us this one, which is this one. Make sense? Right? So now we need to write that this xt here is this signal plus this signal. What is this signal? RT, right? What is this signal?
RT minus 1.
Okay, RT minus 1. And we need to subtract, right?
That's correct.
Alright, or you can see this one is negative RT minus 1. Then you add. It's good? I know we need some time to think, but not that difficult, right? So you understand this representation, unit step and unit ramp, right? So on. Is everything good here? Before I give you another example? Alright, I'll give you another example here. It's more typical. Like this. This equals 2, this equals 5. This is time. And this one, suppose equals 12. What does that mean? That means, okay, I have this signal, I have this switch, you have this circuit here. at t equals 2 seconds, I close this switch. That means this input, which equals which is a 12-volt battery, a DC, applied to your circuit. Okay? At t equals 5 seconds, I open it. So at t5, I open it. This is t equals 5. Then close t equals 2. That is the application. Okay? When t equals 2, I close. Apply this 12 to this circuit. Then at t equals 5 seconds, I open it. No input at all. I want to use these basic signals to represent my input. So what is this input? Anyone want to try? This is the input. Equals what? I want to use this the fundamental basic signals to represent. So we already know the physical meaning. All right? When t equals 2, we apply 12. Then when t equals until t equals 5, then later time we disconnect. I want to use these fundamental signals to represent our action.
So 12U.
Okay, first one we need that's 12. Yes, perfect.
12U.
Alright, so 12 everything. Now you consider this is only 1, and because we already have 12 here, so boost everything from 1 to 12. Alright, so now it's 12. So now this is 1. You consider this is 1. Alright. Then what is
The UT minus 2.
UT minus 2? UT minus 2 give us all 0, then to 1, then all the way to infinity, right? But we need to stop at t equals 5. What's next? Minus? Right? Alright, you look at this. So this is 2, ut minus 2, right? That's ut minus 2. What is ut minus 5? This is 5. ut minus 5. T minus 2, t minus 5, right? This one minus this one. What you have? This one, right? Right? So that's ut minus ut minus 5. And then this one give us only 1, but the original question is this is 12, so you have 12. That's it. This is easy? Good? I know, after class you already has your notes, right? After class you need to review and look at this, right? I give you exercise, after class you think, exercise here. This one. In circuit lab, we call this, what signal is this? A source signal, right? So suppose this one equals 5 seconds. Can be anything, right? So this is 0. So suppose the amplitude equals it's 5. And this is t. So this signal looks like this. Here, or if you like this kind of question, okay, I'll give you another one here. Right? So this is from 0 to 5, and this one from 6 to 11. And then we have another one. Or we can have another one, periodic signals. So you just try. Right? Any questions on this? Okay, we discussed 3 types of a basic CT signals. Now we want to know what's the relationship between these three. Are they totally different? Right? The first one is unit step, right? That's equal to 0. The next one is unit, this is UT. This one is impulse. And this one here is unit ramp. That is what we discussed, right? But I would like to change the order of this. Right? I do this first. I do the impulse first and UT second, like this. Right? Because it's easier to see the relationship. How to get this signal from here? Give you a hand. If you take the integration, so from negative infinity is here. From negative infinity all the way up to this point, what do you get? Negative infinity. Integration up to this point, what do you have? 0, right? Because the signal here equals 0. You do the integration, still get 0. So that is 0. And all the way up to this one, 0, a little bit before that, what you have is 0, right? Now, you come to this point, 0. And you pass that point. So 0 plus, 0 plus, 0 minus. You pass this point. That is the integration of the impulse we here. That gives us a what? 1, right? So once you do the integration, passing this 0, you get 1. So that you get 1. How about the later time? All this part gives us a 0 contribution because there's nothing here. So you just keep this 1. Right? So that means this one, this signal, you do the integration, you get this one. Make sense?
And you integrate it again, you get.
Yes. You take this integration, you get this one. Why? Because this is 1, right? This is 1 dt. What is 1 dt? Equals t. And what is t? T is this one. Is here. Right? Good observation. This one, integration, you get here. This one, integration, you get here. Make sense? Now we go backward. This one, derivative, you get this one, right? Then, derivative again, you get this one. This one, this relationship is useless right now, but later time when we do Laplace transform, inverse Laplace transform, we are going to know this one is very useful. Right? So integration from here and differentiation backward. Following these ideas, you can even do more. Right? You do the integration of this one, you get a quadratic, right? Half t squared. Make sense? Right? Like this one, right? And you do the differentiation of this, what you have. Okay, I don't want to bother you all this, but that's a little bit. The mathematics, they are going to do a lot of differentiations on that. Right? But we need to know only these three. Right? So, relationships. Right? from impulse, unit step, and unit ramp. All this way, integration. That way, differentiation. Remember I said that the impulse is one of the most important concepts. I didn't see this. It's important, but not most important. I didn't see this. What I said is this impulse. So why this one is it's very important. Okay? We have a concept. It's called shifting, or it's called sampling property. Of impulse. Again, as we said, we do not want to bother you with these derivations. For completeness, I need to list here, but we only discuss the conclusion. Conclusion is xt, any continuous time signal, can be represented by integration of negative infinity to positive infinity x tau, then t impulse t minus tau, then d tau. Oh, that is like kind of tricky, but we are going to use this one later time to derive convolution, which is another most important concept, convolution. I just list here. So if you have interest, you can read this one to see how, we have step by step to help you to how to get this conclusion. But if you don't want to do this, that's fine. So, but you need to do this. This is called shifting or sampling property for impulse. Okay, the most difficult part of today is past. The concept of impulse. So any comments, any questions about that before we go to some easier things? So basically, we need to understand the impulse function. And another important is we need to know how to represent a signal with basic continuous time signals. Now let's go back to here. Anyone has an idea what is this? Okay, first one, this one only. Forget this part. This one only. What is this x? RT. 5 RT. We make things easier first. You consider this is only 1. Then we multiply by 5, right? Okay, 1 RT. This part is 5. What's next? This one goes up, and we need to bend this down, right? look at here. We bend this down to level, means we need to minus another unit ramp.
Yeah, minus the exact.
So we need to minus
RT minus 7.
RT minus 5, right? Make sense? Okay, this one could only bend down is this R. So this R goes up, this R goes down, they cancel each other, give us a level. But that level does not occur at 5. This level is this point, right? At this one here. Just like this. Does not give us 0, which we want. We want a 0. See? RT gives us up here, all the way up. Then at this point, you bend down, so you change this into level, but this level is not 0. It will level at this point and continue to the right. That is this one. So RT minus 5, yes, it's bend down into level, but still not what we want. So what's next? So this one gives us these two terms give us this, then all the way to the right. Then we need to minus another RT minus 5. If you give minus another RT, it will bend down again. So it will change into like this. Oh, that's not what we want. So minus something that's good because we want 0 instead of 5. Minus what?
11.
Minus 11? This one here? No, first one, you forget this part. Okay? You only consider this one. We want to minus this constant. The first two terms give us this. What we want is up then this. So we want to remove this one. What function is this? Huh? Unit step, right? Oh yeah, so we minus ut minus 5. That's it. So that is this solve signal. If you have another one from 6 to 11, then this one is minus 6, this is minus 11, this is minus 11, same thing, you just copy, right? Any question on this? Is it good? Okay, you mentioned this one RT. Okay, R. We like this idea. Okay, R. How to draw this one? Yes, it will look like this, but it will here. What's this point? 5, this will be 10, right? We stop here, like this?
Then just keep going.
No, we just continue going down, right? Continue going down towards this one. How about I want this one? Up, down, level.
It'd be plus UT.
You need a plus,
UT.
make this level, make this from down, level.
UT minus 10. Minus 10.
RT or UT?
UT.
UT is a constant, means you shift to everything up and down. You do not change the slope. So RT, right? So RT
Plus 10. Or minus 10.
minus 10. Now feel better? Right? So this one here is, okay, now we summarize. Right? We summarize this. This equals 5. This equals 7. This equals 9. Like this. This equals 1. What is this function? You already know the idea. Just directly write out what this function is. R t minus 5, right? That's the first one. Then at this point we need to write it twice, minus twice, to make it bend to level and bend to down. So minus 2 RT minus 7. Then at this point we do not want to continue going down. We need level. So add RT minus 9. Let's give us this. Any questions? So now, if in real life you want to implement this kind of signal, you know we want to use computers to analyze, right? So you cannot just tell me, oh, at 5, then you linearly increase until 7, then linearly down, then until 9, okay, level. You cannot see like this. You need to tell the computer with functions. That is what we need to tell the computer. Okay, the last part we are going to discuss some typical signals, signal properties. Periodic signal. You know that, right? What is periodic signal? Sine function, cosine function, all these are periodic. So the definition is x t plus capital T equals xt for all t. For all t, for any t. For any small t, if there exists a capital T, this is called periodic function, and t is the period. Next one is right-handed signal. Right-handed signal is, okay, that signal is just like this. From somewhere to the right. Left-handed signal. From somewhere, okay, to the left. Both-sided signal. Extend to both sides. What this signal is? Right-sided, left-sided? Right. How about this one? Suppose this one equals 5. This one is the left-sided signal. What this signal is? I make it easier here. We start from here. That will be equals U negative T. This T equals negative T. Then how about here? From this way to this way. That will be U negative T plus 5. This is 5. So all these are left-sided signal. This one is infinite length. This one is infinite length. Finite length means like this, or like this. It's called finite length or infinite length. right-handed, left-handed, right-sided, left-sided. They use different names. They mean the same thing, right? Handed, sided, doesn't matter. The next is finite length. Okay. Infinite length. The next one is deterministic with random. This one means the signal you can predict, like a Thayer function. You can calculate the values at any time if you are given the representation of the Thayer function. Random signal. Anyone give me an example of a random signal? The thermal noise, right? Every electronics has a thermal noise, and the signal is just totally random. You cannot predict. Or I flip the coin, right? The quarter, right? 0 and 1. Right? So for example, head is 0, right? Tail is 1. I just flip. Right? I do this, you record the result. 0, 1, 0, 1, 0, 0, 1. This signal is random or deterministic? It's random, right? You don't know what next is. So that's random signal. Causal signal. Causal signal means is 0 for negative time. Right? Is UT a causal signal? Is 0 for negative time. If the signal is 0 for negative time, then it is a causal signal. Is UT a causal signal?
Yeah.
Yes. How about UT minus 5? UT minus 5 is this one, right? Is it 0 for negative time? Yes or no? The definition for causal time is the signal is 0 for any negative time. So yes, right? For any negative time here, the signal is equal to 0. Okay. How about the UT plus 5? How to plot UT negative 5? It will be 0, negative 5 here, UT plus 5 like this, right? Is this causal? Is it 0 for all negative time? No. But negative 5, not 0. Negative 4, negative 3, no. So this one is not causal. Okay? Next concept is called anti-causal, right? Just opposite to this causal. So means is 0 for all positive time. For positive t. Is this anti-causal? Anti-causal means 0 for all positive time. Is this anti-causal? No. Is this? No. Is this? No. They are not 0 for positive time. For example, here, when t equals 100, everyone is not 0, right? So that's not, this is not anti-causal. How to change this anti-causal? How about this one? Negative 5 -5, it will like this, right? Is this anti-causal? Yes, because 0 for negative time, for positive time. This one, if you change into a negative t, it will go this way. Is this anti-causal? Yes, it is 0 for positive time. This one change into a u negative t plus 5. So it will do like this, then this way. Is this anti-causal? No. This part, positive time, is not equal to 0. Eh? Then what this signal is? Eh? For both positive and negative, it's still non-zero. Right? That is called a non-causal signal. This one is non-causal. This one is non-causal because it can be non-zero for both positive and negative. Okay, we finished the continuous time signal. Right? Next time we are going to discuss the continuous time systems. We finish the signal. The most important, most difficult part is to understand this unit step and unit impulse, unit ramp, and the technique you need to know is represent a signal with these basic functions. You need to know this. Okay, thank you.